Welcome back to part B of my lectures on supply and demand with graphing and a little bit of algebra. And in the first part, we were graphing this demand equation, 22 minus 1 and a half Q, and price equals 3 plus 0.5 Q for supply. And we found that the equilibrium price is $7.75 and the equilibrium quantity is 9.5 units. And we started to look at some out of equilibrium behavior. The equilibrium is great. It's where you find a quantity and a price such that at that price, the amount that people want to buy, the quantity demanded, is the same as the amount people want to sell, the quantity supplied. But that's only the beginning. It's much more interesting to look at out of equilibrium behavior because when you start looking at other odd things and not just where two lines intersect, you're making sure that you really understand what this model's doing, and that's going to be very important as we go along. And so we found that if we saw people buying and selling 11 units, then it must mean that the price the demanders are paying is 550. We could plug that quantity of 11 into the demand equation and we would be able to see that the price would be $5.50. However, on the other hand, if suppliers are selling 11 units, then the price they must be receiving for their product must be $8.50. And so there's a disconnect here. How is it that the price people are paying is $5.50 and they're getting 11 units, and at the same time the suppliers are receiving more money than the people are paying? Well, there are ways that this can happen sometimes, and we'll talk about those in a later lecture. Now, at the same time, let's look at on the other side here. What if one day we saw demand was the same and supply was the same, but we saw on the same day people buying and selling 5 units, not 9.5, but only 5. What must be happening then? Well, it must be the case that the price people are paying is about $14.25. That is the price that will cause people to want to only buy 5 units. And we said people are buying the 5 units, so it must mean that that's what the price is. Now, on the other hand, the price that businesses are selling must be $5.50 because that's the price on the supply curve that would cause the quantity that businesses want to sell to be 5. Now, to clarify here, let me be clear. I'm saying that people want to buy 5 and businesses want to sell 5. So we're sort of in an equilibrium, but the only way for that to happen would be for people to be paying a high price, like $14.25, and businesses to be receiving a much lower price, like $5.50. Now, how in the world could that happen? Well, it can happen, and the difference in what people pay and the businessman gets to keep could be a tax that the government gets to keep. And we'll analyze that in a later lecture. I'm just looking at some interesting possibilities here to make sure you understand what these points on the demand and supply curve actually mean. So, okay, let's look at some other examples here. Now, let me ask you another question. Looking at this demand curve, at what price would people want to buy none? 0 units. What price would cause the quantity demanded to be 0? Well, we could solve this algebra here if we wanted to, right? Price equals 22 minus 1.5 times 0. Oh yeah, that's the y-intercept. This price of 22 up here, that is the price where people would say, forget it, I want to buy 0 units. Similarly, on the supply curve, any price less than or equal to $3, businesses will say, Forget it. $3, I'm not going to produce anything today. I'm just going to go home. Now, let's look at some other prices. Not the equilibrium price of $7.75, but let's look at another price like $4. Suppose a government official said, you know, $7.75. That's a lot of money to pay. I'm going to do people a favor. I'm going to pass a law saying that it's illegal to charge more than $4. We call a law like that a price ceiling. We call it a price ceiling because it comes down on the price, say at $7.75, and it crushes it, lowers the price. You can't go above the ceiling, just like a balloon. Now, at that price of $4, let's look and see what the demanders would be thinking at that price. The quantity demanded at a price of $4, we can look at this equation and plug in $4. We'll do that in just a second, but let's look at the graph. Price is 4, the quantity demanded 12. People want to buy 12 units at a low price. Makes sense. Now, what are the suppliers thinking at that low price? Well, it looks like the quantity they want to supply is only 2 at a low price of $4. And so this difference between the two, between this 2 and this 12, let me make that a different color here so that we can see that. The difference between the 12 and the 2, that's 10 units, a quantity of 10 difference between how much people want to buy at that low price and how much people want to sell at that low price. And that difference is what we call a shortage. Now, if there's a shortage of a product, that's going to put pressure on the price to go up. Picture 12 people trying to buy the product, but there are only 2 available. This is going to start a bidding war, and it's going to try to push the price up. Now, normally, when the price starts going up in a market, it's going to reduce the amount people want to buy as the price goes up, and it's going to increase the amount people would like to sell until we get to the equilibrium. But with a law like this, a price ceiling, the price can't go up. And so there's going to be this persistent shortage. Or what can happen sometimes is people will start to sell this product in an illegal market called the black market. So that's one example of what can happen in a market like this. Now, let's look at the other hand. What if instead the government passed a law saying that instead of the price being $7.75, the price is going to be much higher? Let's see what will happen in that case. Let's say the government says instead of 4 and instead of $7.75, we want to help the business people out. We're going to raise the price up to $13. Let's see what happens. At a price of $13, let's look at the supply curve over here. How many would this business person or these businesses want to sell at a price of $13? 20 is what it looks like on the graph. Now, how many would people want to buy at a price of $13? How many people will show up to buy this product? Or how many will they buy at $13? Only 6 units. And so let's draw a line at that difference so we can really get an idea of what that looks like. People want to produce and sell 20. People only want to buy 6. So people bring 20 to market, they sell 6. How many are left over? 14. And we call that difference a surplus. They're sold at a surplus store, or you surplus them. And that surplus is going to be 14 units. 20 that people want to sell minus the 6 that are actually purchased. Now, believe it or not, governments do this all the time. They think the price is too high and they try to lower it, or they think the price is too low and they want to raise it, but that leaves either a shortage where people can't buy how many they want to at that price, or a surplus where there are a lot left over that no one wants to buy at that price. Now, the only way to keep this kind of policy going, where there's a surplus of 14 units, is for the government to actually buy those 14 and take them off the market. An example in the United States is in the milk market. The government of the United States has historically, they don't do this as much anymore, had a price floor, raising the price of milk above the equilibrium, and the government buys up that surplus and turns it into cheese and dry milk powder. So if you've ever heard of government cheese in the United States, this is where this government cheese actually comes from. So I hope that by looking at not just the equilibrium, but the out of equilibrium situations, that helps you understand what's going on a demand line and a supply line. And also, let's look at the equations one more time quickly. Let's just verify these two quantities we were looking at here at a price of $13 to make sure that we weren't just guessing those amounts. Now, it's pretty easy to see for that particular example, but a lot of times it won't be. So if that price floor is at $13, and that equals, let's look at the demand equation first. 22 minus 1.5Q. And let me move that over so we can see here. Then if we solve this for Q, subtract 13 from both sides, or sorry, subtract 22 from both sides, we'll end up with negative 9 equals 1.5Q. That's actually negative 1.5Q. Get rid of the negative sign and then solve for Q. Then you can verify that that quantity demanded is going to be 6 quantity demanded once you divide that out. And so Q equals 6. And that's what we saw over here on the demand curve, a quantity of 6 at a price of 13. Now, if we look at the supply equation, looks like here a quantity of 20. Let's just verify that at $13, that equals 3 plus 0.5Q. So 3 plus 0.5Q. Subtract 3 from both sides and we get 10 equals 0.5Q. Divide both sides by a half, and sure enough we get Q equals 20. So even though we can see it clearly on this graph and we got it right, there will be some situations as we go along in this course where you will have to do some basic algebra like this, but it's not going to get any more difficult than what we were looking at right here. So I hope you understand a little better what's going on, and I'll end this lecture here, and I'll have some more videos about supply and demand coming up that will look at more practical applications of using supply and demand with a little less math.